Okay, so today's Java 3 lesson 2. Sorry, not lesson 2, lesson 3. And what we're doing today is classes, class methods, and null. So classes and objects. Classes are another way of packaging useful information together, just like how we learned last week about not last week, but last class about static methods. This is also another way of packaging useful information together so you can use it multiple times. And in a way, classes are more efficient than static methods. And you'll see in a few seconds. And so before, when we imported things to use for file input and output and user input, we were importing packages and also specific classes that were included with Java. And so the reason why you had to import them was mainly because you have to, since they're not like automatically in, and it would take too much time to load all of that. So that's why you have to import specific ones that you want to use. Okay, and then classes are something called objects once you create one in the main method, and I'll go over that, how you create that in a few seconds. So strings are also a type of object, and that's why when we went over primitive data types in Java 1, I believe, that's why strings weren't included in like the primitive data types, because strings are a type of object. And object, just be careful that in this case, the O is capitalized. I know it's because like it's in the beginning of a sentence, but when you're talking about it not in the beginning of the sentence, it's also capitalized. Object, which is another pre-made class, is a superclass of a class. So superclasses will be discussed later, which is next lesson. And classes go after all the brackets of the public class and is a thing on its own. So, and I have like examples of that later. So you can create as many classes as you want. Classes contain attributes, which are basically variables, methods, and constructors. And constructors I'll go over soon as well. The public class, which is the one we've been writing in most, has to be named after the file as a note. So this one doesn't really have to do anything with like today's class really, but just as a general note, you have to name it after the file. Since what we're doing today, like if you name it the wrong thing, then it can cause errors. So just a general implementation of classes. So this is like a general implementation and an example. So this is what you would see in a common class. So you can see the first line is the class vehicle, and this vehicle is basically the name of the class. So you can name this whatever you want, but just notice that classes are usually like the first letter is capitalized. So just pay attention to that. And also you can if you like spot patterns, you can notice that it's pretty similar to the public class, except it doesn't have a public at the beginning. So next after these brackets, you can see down here, see over here, that there's variables. And the main thing about these variables that are different from regular variables is the fact that you don't set values to them. And so this is where you'll create your variables, and they're called instance variables. And I'll go over what they are mainly later on. So these are instance variables, and you can see here how it's basically set up as regular variables with like data types. And notice here how this line is creating two variables. So how this works is that so if you have two variables that you want to create of the same data type, then you can merge them into one line. And so you just put the data type they both have at the beginning, and then their names separated by a comma, and then a semicolon, of course. And then if they're different data types, then you have to put them on separate lines. So you can see here string status and semicolon. Okay, and then next thing here, this is called a constructor. So this thing here with like the brackets. Everything inside here is like the constructor and this thing as well. So this is a constructor with parameters. And you can see here that in between these parentheses, there's regular parameters, just like we saw in static methods. And so what constructors are, basically, they're kind of like methods in a way, but instead of like doing anything or like returning anything, what it does is it sets stuff. So you can see here that when it the parameters are like int g, int m, string status. So what you see here is that down here in between here, you can see gas, which correlates to here, the variables. Gas equals g. So basically you're setting this g that you're passing in to gas. So this is where you set the instance variables. So, and then you can see miles equals m, this dot status equals status. So also just notice this dot status. And what this means is that because this status is the same as this status, and we want to set them to each other. So to differentiate between the two, you have to put this dot status, which means basically this status. We want this status equals the status here. And okay, so that's basically an overview of what the constructor, like what constructor really does. Also notice that you can see here that rather instead of like having like static or void or like any return types, the constructor's first line is mainly just public and then the class name. So be sure to recognize that this constructor, it has to have the same name as the class name. So it has to be the same. Okay, and then down here, after the constructor, you can see that we have a method. And this is called instance methods, so they're not called static methods. And the main reason, the main difference between them is the fact that there's no static here. So it's just public and then void, print info, parentheses. So it looks everything like a static method, and it's basically the same, except for the fact that they're used differently, and they don't this one doesn't have a static in between. But otherwise, it works exactly the same. So that means that you can change this void to a return type, and you can also add parameters within these parentheses, and any code within your would run. So how to use a class. So this is what I was saying about like creating an object. So for classes, you have to create it in, create an object in the main method before you execute any of its methods. So you can see how in this slide, you see that this class, this vehicle class has a method in between because like it's layered in it. So that's what we mean by execute its methods. And so these are called objects when you create it in the main method. So how to create an object for a class is something like this. So what you do first is you put the class name in where the data type usually goes. And this goes with any classes. So whenever you want to create an object of a class, you have to put the class name here. And it works kind of like a data type in a way. So you have to put it here. And this is variable name equals new class name. And then in here is where you would put the parameters, just like how you would do it for static methods. You would put the parameters in the constructor. So basically, in this case, if you go back to here, you can see how in the constructor, it needs an integer, and a string. So that's what you put here, an integer, and a string. So this has to be the same, like same data type as whatever you have in your constructor parameters. And of course, there's a semicolon after it. And the main thing about creating a method is the fact that you have to use the word new. Okay, next, then you use the variable name and then call one of its methods and it'll execute. So example of that would be C, which is this variable up here, c.printinfo. And if you remember, this is one of the one method in the class. So if I put it like this and add a semicolon after it, what it'll output is 500, 1,000, and green, which is what we have up here. And you can see here that's what this printinfo method does as well. It prints the gas and then the miles and the status. And that's exactly what we have here. So constructor. So this is more like a more specific overview of it. So constructor is where the class sets all of its instance variables with parameters that are passed in. If a class doesn't have a constructor, then by default the constructor has no parameters and doesn't do or set anything. And so that might be a problem if you have instance variables but no constructor. So just keep in mind that you kind of have to do it if you want to, like, if you have instance variables. And note, constructors are for setting things, not for returning. Wait, sorry. Yeah, so constructors are for setting things, not for returning anything. And so you'll never see any like return statements inside of a constructor. So also, if you're setting things in a constructor and you have instance variables and parameters that have the same name, then you can use this. So that's what we saw earlier when I used this.status. Yeah, so because instance variables and parameters that might have the same name, so you have to use this dot, whatever the name is, to like differentiate between them. Methods and variables. So the methods are like static methods, except they don't have the static keyword, and they're accessed differently. And I'll go over specifically like the difference between them later on. So otherwise, they're the same as static methods. The instance variable names are what you would be using inside the class if you needed to use it. So for example, in the previous example, when we had like gas, miles, and status, if you had to use it inside the instance method, then you would use those names, so like gas, miles, and status. And they're originally not set when you first create them, then they're set in the constructor, as you saw. Public and private. Okay, so public variables are variables that can be seen by everything, even in other files in the same folder. And what I mean by same folder is if you create a folder in, like, for example, your desktop, and you had like multiple files within it, so like 3 files in it, for example, and they can, so for example, if you had one public class in each of them, then if you had a public variable in one of them, then another file can access that public variable and use what it has, or what it contains, and stuff like that. So that's like a little tidbit. Though I'm not gonna be teaching it much in this class, so just keep in mind that it can do that for public variables and like public methods and constructors as well. But anyways, and the next private variables can only be seen in a class that it's in. And so that's what I mean by class. So for example, if you create a private variable in a class, then only the class can use it. So if you tried to use it in a public class, for example, then it's not going to be able to access it. Same as if it was in like another file, same thing, you're not going to be able to access it. So private variables are mainly used when you don't want another class to directly access it. And you could also use private and public with methods and constructors. So how you would do that was just maybe instead of like public vehicle for a constructor, you can put private vehicle. And that's how you would do it, methods and constructors. So basically just replacing public with private and vice versa. If you use a public class in a different file but in the same folder, you can access it still in your program. So difference between static and instance. So static is what we went over last class with like the static methods. Instance is what we basically went over today with the classes. So static methods are with a class, but not an object. So that means you don't have to create an object. So you saw last week, not last week, I keep saying that, last class, how when we call static methods, we don't have to like make a variable like the object that we have to do today with the classes, but we can just write the name of the method and it would like execute like normal. So that's what I mean by this. So static methods are with a class, so like the public class, but they're not an object. So that means that you don't have to create an object to execute them. Non-static methods are the actions of an object. So that means that if you view the class as like a person, then that means that the methods are like the actions of a person. So basically you can have like a method that's named walk, and that would be like an action. And that's what it means by an object, because you have to create an object to use it as well. So that's why it's an object. So with static and non-static variables, static variables are the properties of a class, while non-static variables are the properties of an object. So same thing with this one. Since static methods are attached to a class, they're properties of the class, but they don't do everything for the class. And they're attached to a public class, of course. And non-static variables are the properties of an object. So again, using like the person kind of analogy. So if you think about it, so if you imagine a class, like a class that you create yourself as a person, then methods are like the actions of the person, and then the variables are like the attributes. So like, what color is the hair? That kind of stuff. How long is the arms? How long is the body? That kind of stuff. They're properties, defining attributes of a person, for example. And moving on, constructors are always non-static. So since you don't see any constructors in like static method, so that's why they're always non-static. So non-static variables and methods are called instance variables and methods, respectively, like I already mentioned. And static variables and methods don't need a construction of an object, while instance variables and methods do. Meaning that you have to specifically write a variable with an object. That's a typo there. But do not need to do that with static methods, as I mentioned. You can just call them. Static methods are called by the class and method name rather than by object. So I'll go over how to do that in a second. But just keep in mind that there's two ways to call static methods. One way is the one we did before, where we can just write the name out. And the other way is the one I'm going to show an example of. So example, if you had a public class named A and a method in that, like a static method, I should make that more clear, named X, you can use a.x to call the method X. So note that this is another way to call static methods besides just writing out its name and the parameters. So if you were calling a method from another public class, this is where it would be used. So this is useful when you're trying to access something from another file, in the same folder. But generally, it would be fine if you just use the regular way, which is just like the X. So null. So objects can be null, meaning that they contain nothing. So example how to set them as null, and you can see here that we use the object class since, as mentioned before, object is like the superclass of all classes, and again, superclasses we'll go over in next class. So the same thing, it's also a type of class. So that's why you can use it here as a data type. And so you can say object O equals null. And so what this does is it makes it contain nothing, basically. So if you try to access something inside a null object, it'll cause a runtime error. So it compiles. So if you compile it, it doesn't do anything. Like it doesn't come up with an error, but it doesn't run. Or at least it tries to run, but it can't run. So null pointer exception is an exception that occurs when a property or method of a null object is accessed. Get and set methods. So since private variables don't allow users to directly access them, we can implement get and set methods to be able to handle them. So to implement them, you would just create a method in the class that returns or sets something. Sets mainly private variables, but you can use it with any other variable as well. So with get methods, others can see certain variables, and with set methods, others can modify them. So comparing objects. So compare objects, use the equals method. And with objects, you can't directly use equals equals, just like you can't do that with strings, since it can cause an error because it compares memory addresses instead of the actual value of the what it contains. So example of how to use the equals method, and you can see here that you have strings here, and yeah, this would be how you'd use it. So it's kind of like the string methods in a way. So you put the first thing you want to compare and dot equals, and inside the parentheses you put the second thing you want to compare. And then if this executes, then it would output true. And yeah, that's about it for this lesson then. I understand that this lesson is a bit really confusing since it's like so many things, and it might be a little bit complicated as well. So make sure that if you're like still confused about it, to make sure to go over the lesson slides and to watch the video again, just to see, just to understand a little bit better. But otherwise, that would be it for the lesson slides, and I'll be putting the class problems in a few seconds. Okay, so these are the class problems for today, and so you can see here that these 4 up here are the main problems, and the rest of these are just challenge problems. But it's good to try challenges once in a while. And so, yeah, so just make sure to do these problems. You don't have to do the challenge problems if you don't want to, but just at least try to do these. But yeah, if you have any questions, comments, or concerns, you can put them down in the comments below, and I will answer them. But otherwise, that would be it for this class. And make sure to review the lesson slides or the video again, just to be sure.